Hi, everyone. Thanks for having me. I hope you're all awake. I'd like to start things off with a question to check if you're awake. So raise your hand if ever, as part of your job, you had to write front-end code. I hope that's a lot of you. Cool. Now keep your hand up if you ever had to write a date picker or a custom select box. Yep, that's right there. The problem, you're not the only one, as you can see around yourself. In fact, if we search on NPM, there's over 1,200 packages for date pickers, just in case you're not fully sure which one you want to choose. And as web developers for a while, we've been asking for like a date picker element or something like that, input type date. It has been in some browsers, but it hasn't really spread, never been standardized. But this is really where web components come into play. And over the next 30 minutes, I would love to talk to you about what web components actually are and why I believe that 2018 is the year where you want to start looking at them. And you might have heard that statement in 2013 if you've been around for a while, and you might have actually heard that in 2011 when web components were kind of brought up the first time. But I truly believe that 2018 is sort of where it's taking off, and we are pretty much more than halfway through the year, and it is looking good, so I'm still convinced of that statement. Cool. So before we kick off, though, I would like to introduce myself. I'm Dominik. I got a lovely introduction already. I do work as a developer evangelist for a company called Twilio. We're an API company that sort of has REST APIs and client-side SDKs to do anything like sending SMS, doing phone calls, video, chat, anything like that. If you want to chat with me about that, happy to do that. We also have a booth outside. Since I'm the only one, if I'm running around, I might not be at the booth. Feel free to still grab a t-shirt or come and hunt me down later and have a chat with me. And as you can see, I'm part of Onesie.js. I'm going to take off the hood, though, because it's getting really warm, and it's sort of like, it fits me. It's not perfect, though, so I'm just going to take that off to make it a bit more comfortable. Cool. So I've been developing for the web for a while now, and sort of during this time, we always had the question of how do we share UI concepts between different projects and between different teams that might have like different technology stacks and different needs. And we came up with a bunch of different solutions inside the community. One of them I call sort of the Bootstrap approach, and that's mainly because that's the first time I encountered it, but it's been certainly around for longer. But it's basically the idea of you go to a website, the documentation of like the framework of choice you want to use, and you copy paste a bunch of CSS and JavaScript that you have no idea if you really need all of it, but you'll just copy it because you think there's smarter people than you that built that stuff. And then you need some component of it, so you search it on the documentation page, and then you just blindly copy paste that code. And this is where the fun part starts, because you realize you're using some templating engine or something like that, and it doesn't really fit with that syntax, so you start adjusting that, and then you're like, well, actually, I want to fill this up with useful content, so where do I replace what, though? I don't like having a heading. Do I need a heading? Can I drop that? Will it break the component? What is MB0? So it's really hard, and like if I drop certain things, I lose accessibility. So there's certainly a lot of challenges around this. And especially for more complex components, that's why we came up with sort of this JavaScript API approach. So you pull in some SDK globally often, and you specify some DOM node with some options for this SDK, and you just say like, dump the component in there, and I don't care what you're doing. So this is sort of what, for example, Google Maps does. So we pull in the global SDK for Google Maps, and then we say, hey, this is my container where I want you to put the map in, and here are the locations and things like that. So at least we know now what things are available as options. We know how to configure it easily, but we need to have some DOM node somewhere available, need to grab it out, and then pass it in. And then the third approach is sort of this like, I call it the share button approach, because like Facebook loves using this for the share button. And it's sort of a hybrid approach. You pull in a global SDK, but it expects a certain format of HTML. So it expects to have an FB root element, so it can dump a bunch of information in there, but then it also expects you to shape your HTML in a certain way and pass all those configuration things as attributes. It's a bit more descriptive than what we had with Bootstrap, for example. And it does provide you the ability to have sort of a fallback, like in this case an A tag, but it also means that in this case, for example, we now have to actually keep these two things in sync. And that, for example, if we want to like use the same link in the A tag as well as in the data href, we need to suddenly start keeping these in sync. You might forget that. So overall, we often end up with sort of a poor developer experience, especially if you start using this with a framework like Vue, React, Angular, because often these discourage you to, for example, access the DOM actively. They're used to using JavaScript modules rather than like having global SDKs. And as a result, people came up with this concept of wrapper components. So we love just bundling the weird stuff up into a component, push that to NPM, and then consume that so we never have to look at the ugly code again. But it does still exist. And this also leads to library fragmentation. So if we look at something like MDL, which is Material Design Lite, so imagine Bootstrap, but for material design, there's one for React, one for Vue, there's one for Preact. These two are like the Preact one and the React one have completely different feature sets they support, even though they both are based on the same library. And they might support different versions, which means that you also have issues around like, are you using the correct version that has the latest security updates, for example? And if the maintainer is not really up to like publishing the new versions, you're lacking behind there as well. So the idea really behind web components is how can we leverage the fact that all these frameworks, every tool that we're using has been designed with using native HTML elements in mind, and how can we use that to build our own components? How can we extend from the HTML element base class to do our own components? Because this way we can use this in A/B testing, we can use this in static websites, as well as in any framework. And this is where web components come really into play, and that's their premise. And most people think of web components as one spec, but it's actually a series of specs that I would like to walk you through. So the first one is custom elements. So custom elements is this concept of being able to extend from the native HTML element by literally doing an extension of the JavaScript class, and then registering this with a browser by using custom elements.define, giving it a tag name. This tag name needs to have a dash in there. This way, the browser vendors are able to ensure that they can still introduce new HTML elements in the future without having to worry about breaking the entire web because everyone overwrote this already. And then we specify which class we actually want to associate with this tag name. And we can also extend built-in elements. So, for example, the HTML input element, and we extend from that, and then we pass that information into the custom elements.define to say that we're extending from that. And once we have that, we can use it like we use any other component. We can do this in a declarative way in our HTML, in our JSX if you want to use that, because we can also use it imperatively. So document.create element, and that's passing in the tag name there. And that's actually what Preact, React, and so on do under the hood anyways, meaning you can actually use these tools as well. When we're talking about custom elements, one thing that is important to keep in mind, and people with all these frameworks coming up tend to forget about that, I actually had a conversation earlier about this, is the difference between attributes and properties. And these sort of have been blurred by a lot of the frameworks, so I want to kind of revisit this. Attributes are a way for you to pass in basic, simple information to the component to help rendering it. And it only supports simple data. So you can only pass in strings or check for the presence of an attribute. That's why disabled equals false is still actually disabling an element, because it just checks for the presence. So it doesn't really care if you put something else on there. And properties are the thing that allow you to access these elements via JavaScript and specify more complex data to this. So whenever you want to pass in an array or an object or something like that, that's where you would do it. Similarly, that's where you assign methods, for example, to it that could trigger things like a start and a stop method on the video element. So this is really for complex elements. And in some frameworks, we see these mixing. So for example, Angular sets properties by default. So does Vue, I think, but they provide ways to also set attributes. You can write the code to keep these two in sync. By default, they're not necessarily kept in sync. And since we're talking about properties actually being JavaScript properties, we can use things like getters and setters and then reflect these back into the attributes. This is common in some cases, like disabled, for example, is a property that is also being reflected back into an attribute. Value, for example, doesn't by default. So another spec is HTML templates. So that's the idea that we can write some markup and then actually that is not being rendered, that where the CSS isn't applied, but that can be cloned really efficiently. And the way we do it is we use the template tag and specify any HTML in there, and this will not be rendered, but we can grab it out of the DOM and actually reclone this node and then append it somewhere else, and then that will actually render it. And this combines sort of with Shadow DOM. So Shadow DOM is the concept of being able to hide the underlying implementation of your component from the user of the component and scope styling, for example, so that the styles that you apply to your web component can't bleed out, and similarly, the styles that the user writes can't affect your component. So instead of using iframes and stuff like that to protect your own component, you can actually use Shadow DOM. And the way we do it is we use the attach shadow method on the HTML element base class. And once we have this shadow root, we can append any kind of element to that. And this will look, the top example is sort of how you would write the code. So we can use our component, we can specify even some child elements in there. And then if we look at it in the dev tools, we'll see a shadow root. Inside there, we see all of the template that we used. And the paragraph that we passed in as a child here will actually appear in the part that is the slot here. It will just appear there, though. It will not actually be placed in there. And that's important because that means that, again, the styling, that we can style the children in our user style sheets, but we can't, but they can't be affected by the shadow root elements. And the fourth spec is HTML imports, and we're going to skip that one, not only for the sake of time, but because it has been declared dead. In the meantime, we got ES modules that solve a lot of those problems already. And so the people decided to drop HTML imports. Obviously, with any sort of new feature, the important thing is what's the support. And the support is actually really good. By now, Firefox recently shipped web components in their major version. Edge finally started last week development on this, so that's the last browser that is actually lacking this support. And once we have that, we have good support. But you can use polyfills to even use it in Edge and stuff like that. The only problem is around Shadow DOM and styling, where you can use a polyfill called Shady CSS, but it is a bit more heavy and therefore a bit harder to use. Why would you care? That's often the typical question. If you're already a React developer, Angular developer, or something, you already have components. Why would you use web components? If you're developing a UI component, be it an open source one or like one that you sell, the nice thing is you suddenly have a larger user base because you're not limiting it down to your React user base or Angular or whatever you use to build that component. Anyone can use this as long as they know how to use HTML. And even if you're not doing that, if you're working in a big company, it allows you to use the same tools for everyone in the company, regardless of what their tools, what the tools are that they chose. So EA did this, for example, by building their entire UI component system using Polymer. They're able to share this with all the product teams, regardless of what stack they're using. And if you're not falling into either of the categories, you're just benefiting from better developer experience because people can polish these components. And since every framework is designed with consuming native elements, you're able to easily consume them as well. Luckily, I can skip this demo, I think, because Madeleine already talked about A-Frame. A-Frame is actually using web components to kind of abstract away the underlying logic of RuhrJS and WebGL, so you don't have to deal with that. And instead, you can just use simple HTML to declare your scenes, to declare your objects in a very descriptive manner. There's a demo here, but basically I'm just modifying the line here, which is an A text element. So for the purpose of time, we're going to skip this now. The other idea is you can use this for progressive enhancement, for example. So my colleague Phil Nash built a web share wrapper that is a web component, and in case the web components aren't supported, you're able to pass in a fallback here, like an A tag that is being rendered then. And if it is supported, he will be able to render specific content. And if the web share API is actually supported, he's able to use that web share API. All right. So if web components are so great, why didn't they take off earlier? They've been around for so long. We've been talking about them for 7 years. And there's multiple reasons. The first one is browser support. It took a while for the browsers to implement this, mainly because it took a long time for the V1 spec to come out. And that's because people didn't really adapt this via polyfills. And that's due to the fact that the API is very low level. It's similar to WebGL, a very low level API. And that's on purpose because it's designed after the extensible web manifesto. And if you're not familiar with that, it's something that the browser vendors, but also people like other folks from NPM and other folks signed to agree on how they're going to bring the web forward. And two specific points in there are that the standards process should really focus on bringing low-level capabilities that are secure and efficient instead of actually telling people this is the solution. Because if we would get a date picker, we would start complaining about how the date picker should look like. And instead, they gave us the possibility to build date pickers rather than giving us a date picker. And the other thing is it should explain existing features. So in this case, the browser already extends HTML element with their own elements. And so they're exposing that. Similar WebGL and others, CSS Houdini, are explaining existing features as well. If you want to learn more about that, Monica gave a great talk last year at Full Frontal called How the Web Sausage Gets Made. I highly recommend checking that out because it explains why it took so long for web components to get standardized. And then, since it's a low-level API, you need higher-level APIs or good tooling around this. And for a long time, it was pretty much you build one using web components or you build your app via Polymer. But by now, there's way more of these solutions. We have specific frameworks that are focused on web components like Stencil or Skate.js. But we also have things like Ember and Angular and Vue looking at how can you take your existing components and export them as web components so that you can spread them. Because the idea of web components is really to allow you to pick your favorite framework to build your stuff, but let other people pick their favorite. So it's not here to kill React or Angular or Vue or something or tell you have to build your entire app using web components. But the things you want to share, you can share them so that other people can pick theirs instead of limiting them to your ecosystem. And with that, I figured, let's do some live coding because I like doing that and build the very last date picker so we never have to do that again. But if you've been here last year, you might have seen Paul's talk about the problems with internationalization of date pickers, and we would probably need like a couple of months to build this. So instead, we're going to build a rating component. And as I said, I'm part of onesie.js, so it's not any rating component, it's going to be an emoji rating component. Because what I want to do is I want to allow you to rate my talk after this talk using pandas, so hopefully you will give me 5 out of 5 pandas, maybe less, we'll see how the live coding goes. And for this, we're going to use lit element. So lit element, if you haven't heard of it, it's written by the Polymer team, but it's designed to be a very basic, base class that's using lit HTML to render so that you can build really easily web components, but it uses fully web standards, meaning we don't need compilation. We're going to use some module bundling, but that's it. And it's powered by lit HTML, which is actually using HTML templates and tagged template strings under the hood. So we can write something like JSX, but it's fully powered by the web. And with that, let's actually switch over and do some coding. All right. So browser on one side. If the code is hard to read, you just scream at me. That's totally fine. So right now, I have a basic, that's the one for later, a basic project. It has a couple of configuration files, mainly because I actually pushed the result to NPM. But the main file here is still empty. And if we look at the dependencies, the only actual dependency that I'm using is lit element. Everything else I'm just using for convenience of development. So I'm using, all right, 10 minutes, I can do that. Cool. Anyways, so let's go into this emoji rating. And as I said, lit element is a base class. So we're going to create a new class similar to what I showed on the slides. I'm going to call this emoji rating. And instead of extending this from HTML element, we're going to extend this from lit element. We need to import this quickly from the Polymer lit element module. And then, so that we don't forget this, we register it with the browser. So we're going to call this emoji rating. We're going to pass in our class here. And now we need a render method because that's the way lit element actually renders stuff. And this render method doesn't return JSX like React, for example, would do. It actually returns lit element. So we're going to use the HTML tag template here. And inside here, we can now write some HTML, like let's render a panda to see that this is working. I'm going to save this, and now we need to consume this. So I have an index.html set up here. We're going to use the emoji rating component. And then we need to obviously pull in the script. So just going to directly reference this here. Need to kick off the development server. Let's switch to this project, npm start. And once this is kicked off, we see the panda here. Cool. We got one panda going. I said it's a rating component, so we need to write a bit more code. So one important thing is obviously we need to pass data in. We can do this by defining a static getter here to tell lit element what we're doing, and we can return what properties are actually available. So I want to have a value one, which is of type number, and then I also want to have a emoji one, so you can change your emoji, for example, to a fox or whatever you prefer. There's type string. And the reason why, and the nice thing here is that lit element will immediately take care of synchronizing these between attributes. You can turn this off if you want to, but you don't. But by default, it will read from attributes and then turn them in. Let's give this some base values. So I'm also going to, first of all, call the super constructor, and then I'm going to set some basic values. I'm going to take min and max as well. So if no value is specified, it's 0, and if no emoji is specified, we're going to use a panda. And now we need to render enough pandas, so I'm going to create an emoji array here. Pull in emoji and the max value here, and then just use some nice JavaScript here to repeat this max times and then spread this. So this just gives us 5 panda emojis in this case. And now we need to render this. So we could just map here, but that's not really efficient. So we're going to use a thing from lit HTML that is called repeat. Where's lit HTML directives repeat. And that just allows us to efficiently iterate over this. So we're going to have a repeat function here. It's super warm on stage. Do not wear a onesie on stage. It's so warm. So we're going to take this and just bind this to the context so we don't have some issues there. And then define this function. We need to prefix it with an underscore because otherwise it's going to become a public method. That's just a thing from lit element, not a web component one. And we get the emoji and the index here, and then we're going to render some HTML, put the emoji in here. We're going to div class emoji, and then I'm also going to pass the data in here because we can use that in a second. And then we're going to put in the emoji here. Save this. And I broke something. Woohoo. Oh no, I have a backslash near the, oh, thank you. So hopefully if I refresh this now, yay, 5 pandas, so that's already better. Let's fix some styling here. And pull some more styling in. Cool, that's already looking better. Forgot a class here. Oh no, that's rating. Reload that, that's already looking good. I need a click function here, so what I'm gonna do for the sake of time, I'm just gonna copy this. So basically what this is, what this is doing is it's just going to read from this index property. We need an active class here. Basically, what we're just checking is if the index is less than this dot value. In that case, we're going to call it active, otherwise empty string. And then that's going to set this active class here. And then we need to pull in the add change event, at click event, just to make sure that whenever it's clicked, we call this function, handle click. And I need to register that here. I'm going to save this, refresh, and now we're able to click this, and it's working. I told you I want to make you vote my talk, so we're going to do one more thing and actually consume this on a page. So I have this beautiful website here. If I reload it, let's full screen this. Cool. So it's missing a rating component right now, so we're going to do that and deploy that. So I have this Angular project here because I figured React is getting so much love here, we're going to use something else. So I have this project set up. It doesn't have much in it except some additional functions here to do the rating. So we're just going to pull this quickly in. So the first thing is I push this to NPM already, so we can pull this in. And then we need to tell Angular that, hey, we're using web components, so there might be some custom elements in there. So we're just going to define this as a schema so that Angular isn't confused about the presence of them. And then we go into the HTML, and all we have to do is write emoji rating, pull this in, save this, and actually start the dev server. Let's close this and reload this. In the meantime, there it is. Cool, so we have this. It doesn't look that nice because I want it in white. So we can write some CSS here and just say emoji rating. And since I said that Shadow DOM kind of blocks style bleeding, we can actually use CSS variables to get through that. Yeah. Color, set that to white, save this. And while this is reloading on one side, the last thing we need to do is listen for changes whenever the value changes. So the way we do that in Angular is do this banana syntax here and call this handle change, get the event, and then switch back, save this, and then go back into the component here and actually register this function, get the event, and then we need to read the value. So this is event.target.value. Set this as the current value. And then the last thing we need to do is we need to actually use the change detector here. 1 minute, I get this. Sorry, I'll be 1 minute, a few minutes over. Sorry for that. Gonna pull this in. Gonna do CDR, detect changes. Changes. There we go. Save this. Remove two things here. Save this. All right. While this is happening, let's switch back to the slides and wrap this up. Cool. All right. No time to talk about Stencil, but Stencil's a great way to use web components if you like the way Angular or React looks like, and you learned a lot from that. I recommend checking that out. Anyways, let's go to the summary. So I want you to think about web components whenever you think about shared UI. So whenever you want to share some part of your UI with other projects, that might be a good solution. Because web components are not here to limit your framework choices. They're here to allow you to use things from other projects as well. Because ultimately, it's all about like you picking your favorite solution and let others pick theirs. If you want to learn more about web components, webcomponents.org sort of explains everything about the basics again and shows a bunch of examples. And custom elements everywhere is a website that's great to figure out if your favorite framework of choice has good support for web components, because they run tests against all of these different frameworks and list both the issues, how to deal with them, as well as what are the related GitHub issues. And if you want to check out different frameworks to auth their web components, there's a web components to-do project that shows all of these. I'm going to share the slides under RuhrJS. I'm going to tweet that out as well, so you can check this out. With that, let's go to vote.dkundel.com. It should be deployed by now, hopefully, fingers crossed. So you can vote for my talk. While you're doing that, it's Hacktoberfest. If you want to contribute to open source and get a free t-shirt, it's a great opportunity. If you open 5 pull requests, you get a free t-shirt from DigitalOcean, GitHub, and Twilio. If you've never contributed to open source, chat with me about Twilio Quest. We have a mission there that teaches you about that. I got stickers. I got no time, so thank you, everyone. I'll be around for the rest of the day if you have any questions.